Welcome to clickmyprojects.com. Here we will discuss about active filter based hybrid on-chip DC to DC converter for point of load voltage regulation. The power supply voltage aggressively scales with each technology generation, making the delivery of the high quality supply voltage to noise sensitive circuit blocks highly challenging. The increase in the number of voltage domains requires new techniques to generate this voltage close to the load circuitry while occupying a small area. The power saving is greater when the voltage regulators are close to the load devices, and size is therefore the primary issue for point of load voltage regulation. Buck converters, which are step-down switching DC to DC converters, are popular because of their high power efficiency. A second-order inductor capacitor passive filter is commonly used in the buck converter. The passive LC components require specification on-chip area. Therefore, the passive components have generally been implemented off-chip. As a consequence of placing their components off-chip, significant voltage drops and bounce are produced at the package level due to the parasitic resistance and inductance between the off-chip components of the voltage converter and the integrated chip. A more efficient area voltage converter structure is a low dropout voltage regulator (LDO). The regulators are implemented on-chip close to the load circuitry for fast and accurate load regulation. These regulators require a large output capacitance to achieve fast load regulations. This capacitor occupies significant on-chip area and is therefore generally implemented off-chip. To produce a voltage regulator appropriate for distributed point of load voltage generation, the passive LC filter within a buck converter is placed with a more area efficient active filter circuit. Prior work is based on hybrid combinations of a switch and a linear DC to DC converter. A switching input voltage is used to generate the desired output voltage, and the converter uses a filter structure to produce a desired output voltage. In this paper, we describe the active filter based DC to DC buck converter, and we propose a system to increase the gain of RC circuit used in operational amplifier by adding a smaller capacitance in series to the last stage of RC circuit. Now I am going to explain flow diagram of our project. In the first stage, we give the input signal as a DC input. That means that unregulated DC input. These were fed back to controller circuits. From the buck converter output, which will be gives pulse output to the control the switching effect of buck DC to DC converter. So for that, in the initial stage of feedback signal, we gives the signal to error amplifier. This will amplify the error signals which are in milli-voltage ranges. So then this was given to active filter stage. In the filtering stage, we extract the error signal which are possible to give triggering pulses for the switching devices. This will fed to comparator circuit. In the comparator, it checks the reference signal and that error amplifier signal from the active filter circuit. After the comparator signal, it gives the pulse generated to switching the effect of DC to DC buck converter circuit. In this stage, it regulated input DC which are in unregulated inputs. Finally, at the load side, we get the regulated output at low area sizes. In this circuit, we give the CMOS circuit as a switching devices for DC to DC buck converter. So here, we provide the active filtering circuit as an RC coupled filtering circuit. So, by using the R and C filtering circuit, our area sizes will be reduced than in the LC controller circuit. Then, Here by using RC coupled filtering circuit, our power factor will be maintained to near to 1 because of removing the leading and lagging effect by using the LC tank circuit as in existing states. Now I am going to explain running procedure of our project. Now just open main converter.mdl file. This is our circuit diagram of our project. This power guide is used to generate the signal processing inclusion. So here I just giving input DC voltages as by using DC source. After that, here I apply active filtering states. These are the controllers which to give the controlling pulse for the switching devices. Here I am using two switching device circuits to provide buck converter DC to DC outputs. This is the comparator stage which compares reference and controlled outputs from amplifier, that is error amplifier. Now just run start simulation by clicking it. In this stage, I run the total simulation at 1 second. We extract the output from scope. Scope 7 displays input DC signal and scope 6 displays the comparator output from error signal and the references voltage which are given to comparator. Then scope 5 displays the controlling pulses to the gate circuit. Then scope 4 displays the control output, that is regulated outputs which are made by buck converter with the help of active filtering circuits. After finishing off running, we can open the scope to view the signals. This is the unregulated input signal. Then this will display the references and signals of from error amplifier. This is displaying controlling pulses. To view the clear view, by right click the screen and click access properties. In this stage, we provide Y minimum as set to 0 and Y maximum is set to 2 and click apply and OK. This will generate the pulses of triggering to provide switching effect in buck converter. And finally, we can display the regulator outputs. So for the input signal, I giving the input voltages at the range of 300. So here I got the buck converter output, that is step down the signal to 200 regulated signal. This is our overall running procedure of our project. Thank you.